Welcome to Unacademy SN YouTube channel. This is K Umamaheswara Rao. Today I will be discussing MSQs and numerical answer type questions on partial differential equations. MSQs and numerical answer type questions on partial differential equations, which I have shared on 21st November and 23rd November in my Telegram channel and Facebook page. I'll be discussing now the solutions of partial differential equations. This topic is useful for civil engineering students and engineering science students in GATE examination. Let u of xt be the solution of initial value problem del square u by del t square equal to 9 into del square u by del x square. It is a wave equation. U of x comma 0 is x plus 5. Del u by del t of x comma 0 is 0. Then you have to find out u of 2 comma 2. Given that del square u by del t square equal to nine into del square u by del x square. Called it equation 1. The boundary conditions are, it is wave equation problem. If you compare with standard form, you will get del square u by del t square equal to a square into del square u by del x square. If you compare with standard form, you will get a square equal to 9. Therefore, a is equal to 3. Next. The initial conditions are provided here. U of x comma 0 is x plus 5. Generally, u of x comma 0 we are going to represent by f of x. F of x. That's why by comparing these two, you can find out f of x is x plus 5. Next, del u by del t of x comma 0 is 0. Now, initially velocity del u by del t of x comma 0 is given that 0. Generally, this is represented by g of x. Del u by del t of x comma 0 is represented by g of x. By comparing these two equations, we can write g of x is 0. I am going to apply D'Alembert's solution of wave equation. D'Alembert's solution of wave equation is u of x comma t is 1 by 2 of f of x minus at plus f of x plus at plus 1 by 2a of integral x minus at to x plus at g of y dy This is the formula. Now in our problem, f of x is x plus 5. Therefore f of x minus 8 is x minus 80 plus 5 plus x plus 80 is f of x plus 80 is x plus 80 plus 5 plus 1 by 2a x minus 80 to x plus 80. G of y is 0 because g of x is 0, that's why g of y is also 0. So after simplification, this term is going to become 0. Now 1 by 2 of x minus 80 plus 5 plus x plus 80 plus 5 minus 80 plus 80 under cancellation. X plus x is 2x. 5 plus 5 is 10. So 2x plus 10 plus 0 plus 0. Now 1 by 2 of 2x plus 10 is x plus 5. Therefore u of x comma t is 1 by 2 of 2x plus 10. Therefore u of x comma t is x plus 5. Now we have to find out u of 2 comma 2, that is 2 plus 5. So the answer is 7. So numerical answer type question, the answer is 7 in this problem. Next problem. The general solution of partial differential equation u into del u by del x plus y into del u by del y equal to x. U into del u by del x plus y into del u by del y equal to x. Now u into del u by del x plus y into del u by del y equal to x. Sagar, in that problem we have to consider the value a for 3, but in your solution, in simplification at under cancellation, there is no role of a in first solution. In second one, integrand is 0, that's why integral value becomes 0. That's why I have not substituted a value. If any term of a is involved in your solution, compulsory you have to substitute. But here minus 80 and plus 80 under cancellation. So first term is not involving a. Second term, anyhow integrand 0, that's why value of integral 0. That's why I need not to substitute a value here. Suppose if first function is 2x plus 2at plus 10, then compulsory we have to substitute a value. Here a is not involving in your solution, that's why I need not to substitute. Catch my point? Did you understand? The solution is not involving a. Suppose if you have 2x plus 2a plus 10, compulsory we have to substitute a value 3 there. Now u into del u by del x plus y into del u by del y equal to x. We have to solve this problem. So first you have to write subsidiary equation subsidiary equation dx by u equal to dy by y equal to dz by x. Now this is 1, 2, 3. So we have to take simultaneous equations. First I am taking 1 and 3. If you take 1 and 3, dx by u equal to this is not dz, this is du, because our dependent variable is not z, our dependent variable is u, that's why du by dx. Okay, now from 1 and 3 we get dx by u equal to du by x. Take cross multiplication, x dx equal to u du. Take integration on both sides. Integral x dx equal to integral u du. From this we can write x square by 2 equal to u square by 2 plus some constant a. From this we can write u square equal to, observe here, from this we can write u square minus x square, u square by 2 minus x square by 2 equal to minus a. So u square minus x square equal to minus 2a. So u square minus x square equal to some constant, you can write k. Instead of 2a minus 2a, I can write some constant k. Now u square equal to x square plus k. Now u equal to square root of x square plus some constant k. Understood? Either you can write u equal to square root of x square plus k, or k equal to u square minus x square. In Lagrangian method we have to write two solutions. Okay, this is one solution. Next, in equation 2 and 3 or 1 and 2, if you take 1 and 2, you will get from 1 and 2 dx by u equal to dy by y. Dx by u equal to dy by y. Observe here, dx by u is nothing but, just now we have calculated here, u is nothing but square root of x square plus k. Square root of x square plus k equal to dy by y. Take integration on both sides. Now integral 1 by square root of x square plus k, you can write log x plus square root of x square plus k equal to log y plus some constant log b for our convenience. X plus square root of x square plus k equal to log yb. So delete logarithms on both sides, you will get yb. Now from this you can write y is equal to x plus square root of x square plus k by b. That means 1 by b of x plus square root of x square plus k. So y equal to 1 by b of x plus square root of x square plus k is nothing but u, right? From this b is equal to x plus u by y. Therefore, the constant b equal to x plus u by y. Otherwise, you can write that constant is y by x plus u. You can write 1 by b equal to y by x plus u. In that manner also you can write. Observe, y by x plus u equal to 1 by b. This is another solution. Understood? Now, the general solution is, the complete solution is, phi of first constant comma second constant equal to 0. First constant is, I have written u square minus x square. So u square minus x square, comma second constant y by x plus u equal to 0. This is one solution. So when you look at the option, first option, one solution. Next, same solution you can write in another form also. Same solution you can write in another form. Observe, u square minus x square equal to function of y by x plus u. This is also another form of solution in Lagrangian form. From this you can write u square equal to x square plus f of y by x plus u. This is writing the solution in another form. You can write the solution in another form. So this is one form, this is another form. So two forms are given in first option and second option. So both first option and second option are correct. Both A and B are correct. MSQ, both A and B are correct in this problem. No, Sagar. Not in other cases. Compulsory we have to substitute the value of A. But in our solution process, after simplification, A is not involved. That's why I need not to substitute. Otherwise, compulsory we have to substitute. If you have A in your solution, you have to substitute A value. If A is not in your solution, you need not to substitute. That I said. Next problem. The second order partial differential equation uxx plus x into uyy equal to 0 if elliptic for x greater than 0, hyperbolic for x greater than 0, elliptic for x less than 0, hyperbolic for x less than 0. So it is a problem designed on classification of second order partial differential equations. If you compare the given differential equation with the standard form, the given partial differential equation is del square u by del x square plus x into del square u by del y square equal to 0. U del square u by del x square plus x into del square u by del y square equal to 0. If you compare this equation with standard form, A is equal to 1, B is equal to 0, C is equal to x. Generally, B square minus 4AC equal to 0, then parabolic. B square minus 4AC equal to 0, then parabolic. Observe here, I will write before that. Now, generally when you compare with standard form, A into del square u by del x square plus B into del square u by del x del y plus C into del square u by del y square plus D into del u by del x plus E into del u by del y equal to F. If B square minus 4AC equal to 0, then parabolic type. If B square minus 4AC less than 0, elliptic. If B square minus 4AC greater than 0, then hyperbolic. This is the concept behind this problem. Now come to our problem. If you calculate B square minus 4AC in this problem, 0 minus 4 into 1 into x minus 4x. Now you have two cases arises. If x negative, if x is less than 0, then B square minus 4AC will be greater than 0. Suppose x is greater than 0, then B square minus 4AC less than 0. Understood? Suppose if x less than 0, B square minus 4AC will be greater than 0, because minus 4 into negative value gives plus 4. So in this case, it is hyperbolic. Suppose if x greater than 0, then B square minus 4AC is less than 0. In that case, it is elliptic. Sir, suppose x equal to 0. If x is 0, then it is parabolic. Now come to the options. Observe, x less than 0 hyperbolic. So x greater than 0 means elliptic. Na? Now x greater than 0 elliptic. First option is correct. X less than 0 hyperbolic. Last option is correct. Therefore, first and last are correct in this problem. A and D are found correct. Devarshi, this method is classification of second order partial differential equations. Classification of second order partial differential equations. This is the procedure of classification. Classification of second order partial differential equation of which type? B square minus 4AC equal to 0 parabolic, less than 0 elliptic, greater than 0 hyperbolic. Next. Here we have two cases. So one is first option, another one is last option. A and D are found correct. In question number 2 now. This one, Lagrangian method. Now, consider the diffusion equation del square u by del x square equal to del u by del t. U of 0 comma t is 0. U of pi comma t is 0. U of x comma 0 is sin x. Then u of pi by 2 comma 1 is, you have to calculate u of pi by 2 comma 1. Observe here. It is a problem on diffusion equation or heat equation. Diffusion equation or heat equation. The standard form of heat equation is the standard form of diffusion equation is del u by del t equal to a square into del square u by del x square. That is actually standard form. In our problem, it is given that del u by del t equal to del square u by del x square. Given that del u by del t equal to del square u by del x square. By comparison, you can understand that a square equal to 1. In this problem, a square value is 1. Now, the boundary conditions are given that the boundary conditions are u of 0 comma t is 0, u of pi comma t is 0. Here u of 0 comma t is 0, u of pi comma t is 0. From this we can understand that L is pi. L is pi. Next, one initial condition is there. The initial condition is u of x comma 0 is sin x. Before going to the initial condition, first I am calling it the standard form is 1. The boundary conditions are u of 0 comma t is 0 and u of pi comma t is 0. Now I am writing one solution equation of equation 1. After applying the boundary conditions, in solution of heat equation, we get u of x comma t equal to, first I am writing general solution, u of x comma t equal to n equal to 1 to infinite bn into sin n pi x by L e power minus n square pi square a square by L square into t. This is actually general solution. In our problem, a square value is 1, L value is pi. So if you substitute these two values in equation 2, you will get the general solution of heat equation according to the given data. Now, if you substitute a square equal to 1 and L equal to pi, we get u of x comma t equal to sigma n equal to 1 to infinite bn sin n pi x by L. If L is pi, pi cancel, then nx will come. So sin nx e power minus, observe here, n square pi square. Here L square is pi square. So pi square cancel. A square is 1. Therefore n square t. Therefore e power minus n square t. Called it equation 3. Now equation 3 is solution of equation 1. Now u of x comma 0 is, now u of x comma 0 is, in the place of t I am substituting 0. Then we will get sigma n equal to 1 to infinite bn sin nx. Called it equation 4. Given that in the data it is given that the initial condition u of x comma 0 is u of x comma 0 is sin x. It is provided in the data. U of x comma 0 is sin x. That's why I am writing sin x. Called it equation 5. From 4 and 5. From 4 and 5. U of x comma 0 is 4 and u of x comma 0 is 5. That's why you can write sin x equal to sigma n equal to 1 to infinite bn sin nx. Bn sin nx. Now sin x equal to, put n equal to 1, b1 sin x plus b2 sin 2x plus b3 sin 3x and so on and so on. Comparing LHS with RHS, you can understand that b1 is 1, b2 is 0, b3 is 0, remaining terms are all 0. Now what we have to do? Substituting. The values of b1, b2, b3 and so on in equation 3, we get general solution of our differential equation. Equation 3, this one. So u of x comma t equal to, you got b1 value 1, remaining all terms are 0. So in the place of n, put n equal to 1. Then you will get b1. b1 means 1. 1 into sin x e power minus t. That's why I am going to write u of x comma t equal to b1. b1 is 1. 1 into sin x into e power minus n square t. N value 1. Therefore t, e power minus t. This is general solution of the given differential equation, the given heat equation, that is equation 6. In equation 6, you have to substitute the required value. Particular solution is required for you. What is that particular solution? U of pi by 2 comma 1. So x is pi by 2, t is 1. So you have to put x equal to pi by 2, t equal to 1. In this general solution, you will get particular solution. U of pi by 2 comma 1 is sin pi by 2 into e power minus 1. Sin pi by 2 is 1. 1 into e power minus 1. That is 1 by e. Answer is here 1 by e. Anant, this is useful for, today's lecture is completely useful for civil engineering branch and engineering sciences branch. Not 1 by pi, 1 by e, e inverse. E inverse is 1 by e. For civil engineering students for GATE and engineering sciences students for GATE. Now, next problem, u of x comma t, x belongs to R, t greater than or equal to 0, be the solution of initial value problem utt equal to uxx. Utt equal to uxx means it is wave equation. utt equal to uxx, and one initial condition is u of x comma 0 is x, another initial condition is ut of x comma 0 is 1. Now u of 2 comma 2, we have to apply D'Alembert solution of wave equation. The standard form of wave equation is del square u by del t square equal to a square into del square u by del x square, given that utt equal to uxx. By comparison, you can say that a square value is 1. Now, given that the initial conditions u of x comma 0 is x, that is given in the data here. Okay, u of x comma 0 is x. Generally we are going to represent u of x comma 0 is f of x. By comparing these two, you can write f of x equal to x. That is one observation. Next, this is one observation. Next, given that ut of x comma 0, initial velocity 1 is provided. Now, in general, we are going to represent ut of x comma 0 by g of x. Therefore, by comparing these two, you can write g of x is 1. Now, I am going to apply D'Alembert solution of wave equation. By applying D'Alembert solution of wave equation, we get u of x comma t is 1 by 2 of f of x minus at plus f of x plus at plus 1 by 2a of x minus at to x plus at into g of y dy. That is 1 by 2 of f of x minus at. F of x is x, so f of x minus at is x minus at. F of x is x, therefore f of x plus at is x plus at. 1 by 2a integral x minus at to x plus at into g of y is 1, because g of x is 1. It is constant function, that's why 1. Now, 1 by 2 of minus at plus at under cancellation, we got 2x plus 1 by 2a integral 1 dy is y, x minus at to x plus at upper limit. Simplify this. 1 by 2 into 2x is x plus 1 by 2a of applying upper limit x plus at, lower limit minus x minus of minus at plus at. From this you can write x plus 1 by 2a of, here plus x and minus x you can cancel, at plus at 2at. After cancelling 2a you will get x plus t. Here a is in cancellation, that's why we need not to substitute a value. Suppose if a is in u of x comma t, then compulsory you have to substitute a value. But here to a are under cancellation, therefore u of x comma t is x plus t. Now we have to find out the value of u of 2 comma 2. So x is 2 and t is 2. U of 2 comma 2 is 2 plus 2, that is 4. Answer is 4. Understood? Next problem. Let u of x comma t is the solution of del u by del t equal to del square u by del x square. It is diffusion equation or heat equation. You can say one-dimensional heat equation. 0 less than x less than 1. U of x comma 0 is 1 plus x plus sin pi x into cos pi x. U of 0 comma t is 1. U of 1 comma t is 2. Then, so it is a problem on one-dimensional heat equation. The standard form of heat equation is del u by del t equal to a square into del square u by del x square. Given that in this problem del u by del t equal to del square u by del x square. From this you can write a square equal to 1. Next, initial conditions. We have two boundary conditions and one initial condition. U of 0 comma t is 1. U of 1 comma t is 2. These two are boundary conditions. These two are boundary conditions. Next, one initial condition is there. By observing the boundary conditions, we have to calculate steady state condition, then transient condition. First, steady state temperature. Generally, steady state temperature is U is independent of time. U is depending on x only at steady state. U is depending on x only. That's why I am taking del square u by del x square equal to 0, because it is not depending on time at steady state. That's why I have written del square u by del x square equal to 0. Therefore u equal to roots are 0 comma 0. Auxiliary equation is m square equal to 0. Therefore roots are 0 comma 0. Therefore the complementary solution is u equal to a plus bx or c1 plus c2x. You can write as per your convenience. Suppose if you write a plus bx, called it equation 2. This is 1. This is 1. Write it equation 2. So here you apply these two boundary conditions. If you apply these two boundary conditions, u of 0 comma t equal to 1, you will get 1 equal to a plus 0, a equal to 1. Apply next boundary condition, u of 1 comma t is 2. U of 1 comma t is 2. By applying that boundary condition in 2, equation 2, 2 equal to, you will get 2 equal to a plus, a is 1 plus bx, b into 1, b, therefore b equal to 1. Substituting a equal to 1, b equal to 1 in equation 2, you will get u equal to, generally steady state is represented by us. us equal to a plus bx. What is a value? A value 1, b value 1, so 1 plus x. Next, we have to calculate ut. To get ut, I mean transient state temperature. To get transient state temperature, generally we are going to represent by ut. Ut of x comma t, right? Here uxt equal to us plus ut of x comma t. So this is steady state. This is 1 plus x. We got ut of x comma t. We have to calculate. How to calculate? Observe. Sigma n equal to 1 to infinite bn sin n pi x by l e power minus n square pi square a square by l square into t. By the method of separation of variables, we are going to get this solution. Okay, earlier you have equation 1, equation 2, this is equation 3. This is transient state, this is steady state. Okay, now in our problem, what is L value, what is A square value, you have to substitute, then write equation 3. That is best. Here means in our problem, in the given problem, what is L value? Observe, L value is 1. Observe, 0 to 1. L value 1. Okay, so I have to substitute L equal to 1. Next, A square value is also 1. Here, A square value is also 1. That's why substituting in the solution, you will get 1 plus x plus sigma n equal to 1 to infinite bn sin n pi x by 1 means n pi x e power minus L square is 1 square 1, A square is 1, so what is left? N square pi square t is left. Called it equation 3. Now in equation 3, put t equal to 0. You will get u of x comma 0. In equation 3, taking t equal to 0, u of x comma 0 will be 1 plus x plus sigma n equal to 1 to infinite bn sin n pi x e power 0 equal to 1, right? This is called equation 4. Given that, where in the data, given that u of x comma 0 is 1 plus x plus 1 plus x plus sin pi x cos pi x is provided. 1 plus x plus sin pi x into cos pi x is provided. This can be written as 1 plus x plus sin 2 pi x by 2. I have written 1 by 2 into 2 sin pi x into cos x. So sin 2 theta by 2. Okay, called it equation 5. Compare 4 and 5. From 4 and 5, you can conclude that, observe, sin n pi x you have here, sin 2 pi x you have here. So n value 2. So B2 equal to 1 by 2. What about B1? 0. B3? 0. B4? 0. Like that. That's why substituting the values of B1, B2, B3, B4 and so on in, this is 4, before that equation 3. In equation 3 we get u of x comma t equal to 1 plus x plus b2 is 1 by 2 sine 2 pi x into e power minus 2 square is 4, e power minus 4 pi square t, e power minus 4 pi square t. This is general solution. In this general solution you have to check option A, option B, option C, option D. Now first option, what we have to calculate? We have to calculate u of 1 by 2 comma 1 by 4. U of 1 by 2 comma 1 by 4. If you substitute here 1 plus 1 by 2 plus, observe, if you put 1 by 4 here, 2 pi by 4, pi by 2 means 1 by 2 into 1. Now here, if you put t equal to 1 by 4 here, 4 cancelled, 4 and 4 cancelled, e power minus pi square, 1 by 2 comma 1 by 4 is, if you put x is 1 by 2, this gives 0. 1 minute. X is 1 by 2 now. So if you put x equal to 1 by 2 sine 2 pi by 2, sine pi 0. That's why this term 0. That is 3 by 2. 3 by 2. First option is 3 by 2. What they have provided? 3 by 2. Therefore first option is correct. Next, it is MSQ. That's why we have to check one by one. Next, u of 1 by 2 comma 1 by 2. Second option, u of 1 by 2 comma 1 by 2. 1 plus 1 by 2 plus 1 by 2. So x is 1 by 2. So sin pi 0. So 1 plus 1 by 2 is 3 by 2. Second option is also 3 by 2. What they have provided? 3 by 2. So that is also correct. Second option is also correct. Okay. Next, we have to check third option. U of 1 by 4 comma 3 by 4. U of 1 by 4 comma 3 by 4. Third option. U of 1 by 4 comma 3 by 4. 1 plus 1 by 4 plus, if you put 3 by 4, 1 by 4 in the place of x, 2 pi by 4, pi by 2 means 1. 1 by 2 into 1 into e power, t is 3 by 4, so 4 cancel, minus 3 pi square. Third option, 1 plus 1 by 4 plus 1 by 2 into e power minus 3 pi square. So 5 by 4 plus 1 plus 1 by 4 is 5 by 4 na? So 5 by 4 plus 1 by 2 into e power minus 3 pi square. 5 by 4 plus 1 by 2 into e power minus 3 pi square. That is also true. Next, 5 by 4 plus 1 by 2 into e power minus 3 pi square. Next, fourth option, 1 by 4 comma 1 we have to calculate. u of 1 by 4 comma 1. Next option, if you put 1 by 4 comma 1, 1 plus 1 by 4, okay, 1 by 4, 2 pi by 4, pi by 2, 1 by 2 into 1 into e power, if you put t equal to 1, e power minus 4 pi square. Verify. 5 by 4 plus e power minus 4 pi square by 2. 5 by 4 plus e power minus 4 pi square by 2. Last option is also correct. A, B, C, D. All the options are found correct in this problem. Understood? Next problem. xy into del z by del x plus x square minus y square into del z by del y equal to xyz. Which of the following is true? The partial differential equation is first order first degree. Yes, it is first order first degree. It is true. The partial differential equation is first order but not first degree. This is false. The differential equation is linear and the differential equation is non-linear, which is found correct. So what is dependent variable? Z is dependent variable. Independent variables are x and y. Now the dependent variable occurred with the degree 1. If the dependent variable is occurred with degree 1, then it is linear. So here del z by del x power 1, del z by del y power 1. Understood? Here xy into del z by del x plus x square minus y square into del z by del y equal to xyz. So clearly this equation is linear. Non-linear is false. So first option and third option are found correct. Next, which of the following is parabolic? So in each and every option you have to check b square minus 4ac. Compare a value 1, b value 0, c value 1. b square minus 4ac is, I'll check option wise. Verify b square minus 4ac in first option. Option A value, B value, C value. A value is 1, B value 0, C value 1. B square minus 4AC is 0 minus 4 into 1 into 1 minus 4. Negative. Negative means elliptic. In the problem he has questioned parabolic, so it is elliptic. So option A is incorrect. False. Next, heat equation. In this, in option B, what is A value? K. A value K, B value 0, C value 0. Therefore, b square minus 4ac value 0, parabolic. So option B is true. This is true. So one option is correct. Next, wave equation. So here a value a square, b value a square, a value a square, c value a square, b value 0. Understood? A value a square. Option C, A value a square, B value 0, C value a square. Therefore, b square minus 4ac, 0 minus 4a square into a square, negative. Negative means elliptic. Next, option D, last option. A, B, C, B square minus 4AC. We have to calculate. Now, what is A value in option D? A value 1, B value minus 2, C value 1. 1 minus 2, 1. B square 4. 4AC 4. 4 minus 4, 0. Then parabolic. So, last option is also parabolic. Third option is false. Fourth option is true. So, correct answers are B and D. Both B and D are found correct. Here, non-linear. 1 minute. Z is here, na? So it is true, it is false. A and D are found correct. Madhukar. If you take Z this side, it is under multiplication, right? Now, next problem. Del u by del t equal to a square into del square by del x square with initial condition u of x comma 0 is 50x by k. The boundary conditions are u of 0 comma t equal to u of k comma t equal to 0. Here it is a heat equation, but we have to apply Fourier series solution of heat equation. Now, del u by del t equal to a square into del square by del x square. Initial condition is u of x comma 0 is 50x by k. U of 0 comma t is 0, u of k comma t is 0. These are the boundary conditions. This is initial condition. Now, the standard form of heat equation is del u by del t equal to a square into del square u by del x square. Called it 1. Now, the boundary conditions are u of 0 comma t equal to 0, u of k comma t equal to 0. These are the two boundary conditions he has provided. By that, you can understand that L equal to k. After applying the boundary conditions, in solution of heat equation, we get u of x comma t equal to sigma n equal to 1 to infinite bn sin n pi x by L actually. So here L is k, therefore n pi x by k. E power minus n square pi square a square by L square is k square into t. That is called equation 2. You will get. Equation 2 is provided among one of the option, that is second option. The general solution is u of x comma t is bn sin n pi x by k e power minus n square a square pi square t by k square. Okay, so second option. Next, particular solution. How to get particular solution? You have to implement initial condition. What is initial condition? U of x comma 0 is 50x by k. So in equation 2, In equation 2, put t equal to 0. If you put t equal to 0, u of x comma 0 will come. That is sigma n equal to 1 to infinite bn sin n pi x by L. That is called equation 3. Given that u of x comma 0 is 50x by k, called it equation 4. From 3 and 4 we can write 50x by k equal to sigma n equal to 1 to infinite bn sin n pi x by L, called it 5. If you look at right hand side series is a Fourier series form. Left hand side you have algebraic function. How to compare and how to get the value of bn with the help of Fourier series? You have to write here, which is in the form of half range Fourier sine series in the interval 0 to k. By using Fourier sine series formula, you have to calculate the value of bn. So where bn is given by 2 by L, actually here L is k, that's why 2 by k. 0 to L is k, that's why 0 to k. f of x is 50x by k, that is given in the data here. Sin n pi x by L, n pi x by k dx. Now 50 by k, if you pull outside 50 by k into 2 by k, 100 by k, 0 to k, x sin n pi x by k dx. We have to apply here integration by parts. By applying integration by parts and applying the limits 0 to k, we will get 100 by k by parts. 100 by k multiplied with 100 by k or k square, 50x by k and 50x by k and 2 by k, so 100 by k square. So 100 by k square into, after applying by parts and simplification, you will get minus 1 whole power n plus 1 by n pi will come. Understood? Into k square it also will come. K square are under cancellation. You will get 100 by n pi minus 1 whole power n plus 1. Now what we have to do? Substituting this value. Substituting the value of bn in equation 2, we get particular solution. U of x comma t equal to what is bn value? 100 by n pi sigma n equal to 1 to infinite 100 by n pi minus 1 whole power n plus 1 sin n pi x by k e power minus, observe here, n square pi square a square k square by t. N square pi square a square by k square into t. This is the final solution, particular solution of the given heat equation. This is 6. 100 by n pi into minus 1 whole power n plus 1. Look at the options. Third option, 100 by pi, here n minus 1 whole power n plus 1. So third option. So both B and C are found correct in this problem. Understood? Next. Next problem. This is wave equation. Wave equation, because del square u by del t square equal to del square u by del x square. U of x comma 0 is 2x square. Ut of x comma 0 is 0. This is f. This is g. A square is 1. That's why A is 1. So we have to apply D'Alembert solution of wave equation. By D'Alembert solution of wave equation is u of x comma t is 1 by 2 of f of x minus at plus f of x plus at plus 1 by 2a of x minus at to x plus at into g of y dy. Now observe, 1 by 2 of f of x plus at. What is f of x? 2x square. So 2 into x minus at ka whole square. 2 into x plus at whole square plus 1 by 2a of x minus at to x plus at, g of y is 0, 0 dy. After simplification, anyhow this term is going to become 0. What about first term? Take 2 common. Here 2, here 2. Take 2 common. Right outside. 2 by 2 of x minus at whole square plus x plus at whole square. 2 cancelled. A minus b whole square plus a plus b whole square form. So 2 into a square plus b square. Therefore u of x comma t is 2 into a square means x square, b square means a square t square. In this problem, what is a square value? 1. That's why I am going to substitute a square value 1. Since a square equal to 1, here we have a square. That's why we are going to substitute. U of x comma t is since a square is 1, that's why I am writing here 2 into x square plus t square. Since a square equal to 1, that's why from this we got this step. Now first option, u of what we have to calculate in first option, second option, third option, fourth option, we are going to cross check. Now first option we have to calculate 1 comma 0, second option 0 comma 1, 1 comma 0, 0 comma 1, 1 by 2 comma 0, 0 comma 1 by 2. These are the given options. Now I am going to find out u of 1 comma 0, 2 into 1 square plus 0 square, 2. U of 0 comma 1, 2 into 0 square plus 1 square, 2. 2 of 1 by 2 whole square plus 0, 2 by 4 is 1 by 2. U of 0 square plus 1 by 2 whole square, that is 2 of 2 by 4, that is 1 by 2. So first option, first two options are 2 comma 2, next two options are 1 by 2 comma 1 by 2. I am cross checking. First option is not 2, so this is false. Second option is 2, true. Third option is true, 1 by 2. Fourth option is true. So B, C, D are found correct in this problem. B, C, D. B, C, D. Three options are found correct. Understood? So here we got 2, but in first option they have provided 1. That's why only first option is false. Remaining 3 options are true. It is MSQ. That's why B, C, D are found correct. Now, understood? Unacademy is introducing new subscription plan for 18 months for ESE and GATE category. In plus courses, you have DPPs, weekly monthly tests, doubt clearing sessions, live and interactive lecture, unlimited access. Buy one subscription. Use code KUR75 to get the subscription, either iconic or plus. Thank you.